Hello, everybody's coming in. You should see the desktop now and everything. You should be able to hear me. Does everything seem okay? Can you hear me? Yeah, I'm not muted. Can you hear me? Do you see the desktop?
Yes.
Okay, great. Thanks. Okay. I'll wait a second. Well, there's about half the people are in the class right now. Still some more to come in. Okay, what we're going to do today is start the Java threads examples. Okay, so there's two reading assignments about that can get you started with Java threads. This first one especially has got real good examples. This reading here comes, the first few sections of it are real clear, good examples of how to get started with Java threads. So we're going to do similar examples. If you want to download his code, there's a link to the code that will go with those examples. And there's another reading assignment today to go past. This reading assignment was for the first couple sections of this chapter. Here's a reading assignment starting with the fourth section of the chapter. So starting about synchronization. Synchronizing is when we eliminate race conditions. Okay, so we didn't really talk about synchronizing with P threads because that's where we want to leave off and switch to Java threads. But we showed we showed one synchronization, the mutex and P threads. So this is Java's version of synchronization. Okay, so that's and then this is another mutual exclusion, the idea of a mutex, and synchronization. Here's another reading about that. So there's two different readings about the synchronization in Java. Okay, so that's a reading assignment. And then if you're interested, here's a reading reading. It's a real high level overview of Java threads. Okay, it's from IBM. It's written by one of the designers of the Java language, very famous person, this guy here. He's one of the designers of Java. And this is, he wrote a short introduction, an overview of Java threads. And it's kind of nice. And if you're interested, here's a lot of what else he's written. Yeah, see, he's the Java language architect. Okay, he's either the lead or one of the lead peoples in designing Java right now. He's not the original designer of the Java language, but he seems to be the person who's taken over. I think he is now the head of Java language development, but he's not the originator of the Java language. But he's a really, really good, he does really amazing stuff. So he wrote this introduction to Java threads, and it's kind of nice. Okay, so we're going to look at the basic examples today, and then next week we'll start looking at the mutual exclusion and synchronization with Java. Okay, so what we want to do today is look at these Java thread examples, but compare them to the P thread examples. I wrote the Java thread examples to parallel the P thread examples, so I'm going to download both of them. And my idea is that P threads are a little bit easier to understand, but Java threads are a lot easier to work with in the long run. Okay. So it's maybe easier to introduce threads with P threads, but then there's a lot better library support for threads in Java. And in the real world right now, not so many people are writing P threads program, but a lot of people are writing parallel Java programs. So parallel Java programming is really common right now. Parallel P threads programming is not that common. It's common if you're writing real low level stuff, like you're working on the Linux kernel, or you're working on the Windows kernel, or you're writing a web server or a database server. So if you're writing real low level things like that, you might be using P threads. But anything higher than those, anything higher level than the web server or the database server or the operating system itself is almost always these days going to be written in Java or some other higher level language, maybe C++, but not, C++ has its own thread library, just like Java has a thread library. So if you're programming C++, you probably wouldn't use P threads, you'd use C++'s threading library, just like we're going to use Java's threading library, and it's got a lot of support. So I think quite a few people use the C++ threading library, but I think the biggest use right now is the Java libraries. Okay, and the P threads for real low level stuff. They were the original threads, and they're the threads that the operating system is built on. Like I say, it databases, web servers, low-level things like that tend to be written using P threads. Okay. Now, okay, I don't need these zip files. Let me delete them. Okay. Now, if you open the P threads folder, this is our first version. So this is the version we did at the beginning. So this has the thread versus function examples in it. Okay. And then here in the Java threads, there's thread versus function. So they're meant to be real similar. Okay. So the idea is that we can compare these Java versions with the pthread version. I'm going to delete all these things here to make this folder a little less cluttered, because we don't need these things right now. Okay. Okay. So these are not sorted right. Okay, there. Okay, there's the examples. There's the pthread examples. Here's the Java thread examples. Okay, now remember when we started with the pthread example, well, we started with an example where here's the function, and eventually we know that we can create a thread in that function, but originally we just called the function. Okay, so we just treated it as a function, not as a thread. Okay, and then when we get to this version, we say, well, now let's create a thread out of that function. So now the exact same functions. Okay, the exact same functions. Oh, these are the different examples. I meant. Okay. The exact same functions. On the left, they're being called as threads. On the right, they're being called as functions. Okay. Here, call the functions, create the threads. But notice that syntactically, a thread just is a function. Now, Java is going to do the same thing. Java is going to take pretty much the same approach. A thread is a function. But the thing is going to be real confusing, because a thread is going to be a function wrapped in one object, wrapped in another object. So it's going to be, this is where when we turn to the Java example, you'll see what I mean, that here it's real straightforward. You've got this function, and you can either create a thread in it or call it. Okay. Yeah. From syntactically, it just is a function. And in another example, we did both. In one of the examples, we called one of these as a function and created one of them as a thread. Okay. So you have your choice. I mean, they are functions, but they can, because they have this signature, they can be used to create a thread. You can't create a thread out of an arbitrary function. You can only create a thread out of a function that takes a pointer to void parameter and returns a pointer to void. Okay, so in pthreads, you can't just take any function and create a thread out of it. But if you write a function that takes this signature, that has this signature, any function with that signature can be passed to create thread, and you can create a thread in that function. Okay. Now let's look at the. Oh, I'll leave this. Let's see. Now let's open the Java the equivalent Java ones. Okay. Well, let me close this one and open the Java one. Okay. Now, here is the function that will be a to be a thread. It's wrapped in a class that implements the runnable interface. Okay. Java does not let you have functions that sit by themselves. So if we go over here to the C version, the C language just lets you have a function sitting there. Essentially, that's what main does. Main just sits there. It's at the top level of your program. No function can be at the top level of a Java program. The top level of a Java program is a class. So the functions are all sitting inside of a class. So the main method sits inside of this class. So here, the main method's at the top level. Notice the indentation matters. Indentation is important because it shows you the structure of things. So here, main is sitting at the top level. Here, main is a static method of a class. Okay. Now, this is the public class of this file. This is a private class of the file. So my function is sitting inside of another class. Now, if I can make that class a separate file and make it a public class, but to make things simpler, I kept this class as a private class in this file. In Java, a file can hold multiple classes, but only one of them can be public. And that public class should be the name of the file. So every Java file contains one public class, and the public class has the name of the file. The Java file can hold as many private classes. Notice you don't put the word private in front of here. If you put the word private in front of here, you'll get a compiler error, which is really stupid of them. So private classes don't have the keyword private. If I compile this, see, it's going to complain that I'm not supposed to put the word private in front of it, even though that's what it is. It's a private class. Everywhere else, you denote things using the keywords public and private. But with classes, public is denoted with the keyword public and private is denoted with no keyword. I think that's a really dumb design, but that's the way they did it. So this file's got one public class and two private classes. This is one of my thread functions analogous to this example. There's one of my thread functions, there's one of my thread functions. Here, I can give the function any name I want, and it should take a pointer to void and return a pointer to void. In Java, the function has to be named run, and it takes no parameters and returns no parameter. No. Notice that the C function takes one parameter and returns a pointer. The Java function takes no parameters and returns nothing. Now, you might wonder, how the heck do you get anything in and out of that function? And we'll see later, it's trickier. Here, you get things into the thread function there, and you get things out through that pointer, okay? Well, Java, the thread function doesn't take anything in, and it doesn't give you anything back out. So we'll have to see what it is anything you want to go in and come out of this function become instance variables in this class. So you use the class that wraps around the function as where you put the inputs and outputs to this function, which is very much using object-oriented programming. So it's actually kind of clever. Instead of the function needing parameters, this object will hold fields. Okay, but so what we do is we wrap this function in a class. That's the first thing we have to do. Then we have to, well, okay, now here I'm just going to run those functions. So I create an instance of the class, then I can run the function. Notice it's a two-step process. I have to create an instance of this class. Then when I have an object of this class, then I can call that function in the object. Notice that's a lot more indirect than over here. Here I just called the function. The function's top level of my program, and I just call it. Okay, function's at the top level of my program, and I just call it. Over here, the function's wrapped in a class. So if I want to call that function, I need an instance of the class. Okay, and I call the class function. I can call this over here. I can give this function any name I want. Here, the function must be called run, but I can give this class any name I want. Okay, so I called the class function one. Okay, so the function must be called run, but the class can be given any name it want, and it has to implement the runnable interface. So class function implements runnable. That's going to set me up ready to create a thread, but I'm not creating a thread. I'm just going to call these functions. So I just hit compile it and run it, and it does exactly the same thing as the Windows example did. It prints out one of the threads, prints out one prints out hello from thread one in lowercase, the other one prints out hello from thread one in uppercase, just like the C version. So it prints out exactly the same thing. And then put a sleep in between. So it says hello, sleeps, and then the rest of the hello. Hello, sleep, and then the rest of the hello. Okay. This one says thread one, both. Let's see. Why did I have a little misprint here? Oh, I'm the thread. They're running on the same thread, so they have the same thread ID. So yeah, the C version, I just numbered these 1 and 2 because I wasn't calling the thread ID number here. So I made a little change here. So this is actually getting its thread ID number, and this is getting its thread ID number. Over here, these things don't have thread ID numbers. They have the thread ID number they're running on the main thread. So I could have had these guys print out the main thread ID number. And that's what this are doing. Right now, notice that when you run it, they both say from thread 1, because thread 1 is the main thread. See, those functions were both called on the main thread. When we build threads out of them, each one of these 2 threads will have a different thread ID number. Okay, but the main thread is number 1. Okay, Java makes the main thread number 1. Okay, all right. So this is the first step to getting threads. I need a function called run embedded in a class that implements Runnable. I have to create an instance of the class, and then I can call the function. Okay. Now, next thing to do is, instead of calling the function, we'll replace these 2 lines with lines that create a thread. Like over here, instead of calling the functions, the next step was to replace the calling of the functions with a creation of threads. That's what we're going to do now with the Java. We'll replace the calling of the functions with the creation of a thread. Okay, so here's the version of Java. This one creates the thread. Okay. Okay, I changed the name of the class from function 1 to thread 1 because now I'm going to use it as a thread instead of as a function. But there's 2 ways to do this. This is another, well, okay. Yes, I should have done this version first. I should have numbered these a little bit differently. No, that's not the one I want either. Unfortunately, Java's got so many ways of doing this. Here's version 3. Okay, there's so many ways. Okay, we'll stick with this one. We'll stick with the way I have it. Okay, so over here, I had a class function that implements Runnable. Okay, now I'm going to do something a little bit different. I'm going to quit, and notice the code here is exactly the same, but I'm going to call it a thread class that extends thread. Instead of implementing Runnable, it extends thread. Okay, and then I create 2 instances of this thread class. Instead of creating 2, so here I created 2 instances of my function and ran them. Now I'm going to create 2 instances of my thread, and well, here I'm not starting them as threads. Actually, I'm still just running them. Okay, so this is still version 1, right? This is 2 ways to run the functions. I'm sorry, this is not creating the thread yet. This is Java has 2 ways of doing this. The 2 ways are implementing Runnable and extending thread. So I'm still doing this version of pthreads version. I'm still doing this one of running the functions, not creating threads. But there's 2 ways to run them as functions. And this is going to lead to 2 different ways of creating threads. Java fundamentally has 2 different ways of creating threads. Okay, and this is one reason why I keep saying the Java version is so much more confusing. If you open 2 books on Java threads, you might think you're reading about 2 different languages, because one book will tell you to create threads one way, the other book will tell you to create threads the other way, because there's 2 ways. And then if you keep on reading, you'll eventually see where one of the books shows you the other way and the other book shows you the other way. But at the beginning, you'll get confused because they seem to be talking about 2 completely different things. Because the job, and nobody agrees on which is the better way to create a thread. So you have 2 ways of starting out: a class that implements Runnable, or a class that extends thread. Okay, this is using inheritance. This is using implementation. Okay, notice that what's inside here is exactly what's inside here. Okay, that part doesn't, I even wrote these carefully so that the code would line up. See how the code lines up real carefully. This is the version that implements Runnable. This is the version that extends thread. What's inside here is exactly the same thing. Okay. But in both of these cases, I'm running the function. I'm saying run the function, run the run function, run the run function from that object, run the run function from that other object. And that's what I'm doing here. Run the run function from that object and run the run function from this other object. Okay. And this one does exactly the same thing as the other one does. It just behaves exactly the same way. Okay. So now we've got the setup for the two ways to create threads in Java. There's a set that, like C, here's the setup for C. You define two functions. As long as they have this signature, you can potentially create threads of them. This one doesn't, but you could create threads of them. Okay, in Java, you can do it two ways. You can create a class that implements Runnable, but the function's got to be called run, or you could create a thread that extends a class that extends thread and it implements run. Okay, the function's got to be called run. Okay, now, okay, so here I'm running them. Okay, now version 2. Okay, so this is where version 2, I'm sorry, number 2. See, here we have number 2 version 1, number 2 version 2, because Java has two ways of doing this. So there's two ways in Java to turn a function into a thread. Okay. Okay. Now we're back to the run implements Runnable. So I'll close this one. So here's the implements Runnable. Here's implements Runnable. Okay. Now I'm going to switch from this guy being a function. This guy, this guy was a function. Now it's going to turn into a thread. Okay. So we're going to switch from function to thread. Okay. Now how am I going to do that? Here, I instantiated the objects and called the function in the objects. Okay. Now, here's the confusing part. I have to instantiate the objects that hold the functions. Then I have to instantiate thread objects that hold the objects that hold the function. This is what I said a minute ago, that you have to wrap a function inside of an object and wrap that object inside of another object. So you got to take this function, wrap it inside this thing that implements Runnable, then wrap that inside of a thread object. Okay, thread object holds Runnable object holds run function. Then you start the threads. Okay, you don't create a thread. In C, we created a thread. In Java, we start a thread. This is creating the thread object. Creating a thread object does not create a thread. Creating a thread object creates a thread object, and it does not start a thread. It doesn't create a thread control block. The thread control block doesn't get created till you call start. This is another confusing thing. Creating a thread object does not create a thread. Creating a thread object creates a Java thread object. The thread control block that the operating system actually thinks is the thread doesn't get created till you call start. In the C version, when you call pthread create, you're creating the thread control block that is the thread, and the thread starts up running right away. You don't need to start the thread. This creates the thread, and the thread automatically starts on you. So this creates the thread control block, and the operating system just, when it feels like, immediately launches the thread. You don't separately say start the thread. You just create it. Okay. In Java, you have to do this kind of three-step process, actually. First, you have to create the object that holds the function. Then you have to create the object that is Java's notion of a thread object, but that does not create a thread control block. The operating system doesn't consider this a thread. Then you start the thread. Then the operating system sees it as a thread. Starting the thread creates the thread control block. So it takes 3 steps. Okay. Create the object that holds the function. Create the object that Java thinks of as the thread. start the thread, which tells the operating system to really start the thread. Then I start each of the two threads, and now the two threads, now just like over here, I join the threads to wait till they're done. Similarly in Java, I join the threads until they're done. But I have to wrap these in a try catch block. I can't just join the threads. Java is not quite that simple. In pthreads, I just create the threads and wait. Okay. Notice the pthread stuff is a lot more direct and straightforward. It's in the long run, it's harder to work with, but at an introductory level, it's way less stuff. It's way more direct. You know, there's the thread functions that creates a thread in the thread function, and this waits for it to be done. Okay, over here in Java, there's the thread function wrapped in a runnable interface. Then I instantiate the runnable object. Then I use the runnable object to instantiate a thread object. Then I can start the thread. Then I can join the thread, but I have to wrap that in a try catch block. Okay. Right. Now, if this will compile and run, and now we get the interleaved output. See, now the two threads are running simultaneously. So now I get this output that's jumbled up. Okay. The first thread starts up and then it sleeps, and then the second thread starts up and it sleeps, and then every time I run it, now here it went first thread, second thread, first thread, second thread. But the order doesn't have to be that way. Let's see if I run it a bunch of times. Eventually, I'll get a slightly different order that output. It's such a simple thread. It may take a long time because that's kind of the natural thing. Thread one, thread two, thread one, just to alternate thread one, thread two, thread one, thread two. But they both sleep for 1 second. So when like thread one prints this and then sleeps, thread two prints this and then sleeps. They could wake up from their sleep at the same time. So they don't have to go back thread one, thread two. When they wake up, the operating system could just say, well, I'll just run thread two first. We saw that in the pthread one. It may not happen very often. Yeah. If you keep running this, eventually it'll happen. There, finally. Okay. I got thread. Oh, here I got thread two, thread one, thread two, thread one. Ah, interesting. I didn't get thread one, thread two, thread two, thread one. I got thread two, thread one, thread two, thread one. Okay. Okay. Yeah. And this was thread one, thread two, thread one, thread two. Okay. Most of them were thread one, thread two, thread one, thread two, which is kind of the easiest order because we started thread one first. It'll start up, it'll print its hello, then go to sleep. And then like a slight tiny instant later, thread two will start up, print its hello, and then go to sleep. But these two guys could wake up from their sleep essentially at the same time. I mean, thread one goes to sleep a tiny fraction of a second before thread two goes to sleep, but there's no reason why when they wake up, they have to be scheduled in the same order. And actually, we saw here, actually somehow thread two printed out its hello before thread one did. So that meant that this thread one got started, but it didn't really start. And then thread two got started and it got scheduled first. So thread one got started, but the scheduler did not run it. The scheduler just said, I'll wait a little while. Then thread two got started and the scheduler said, okay, I'll run thread two first for whatever reason. Okay. So you could get you can get several different orders. Let's see if we get another order. Okay, there was 1, 2, 1, 2. That was again 1, 2, 1, 2 is probably going to be way most common order. I'm trying to get one. I actually want to see 1, 2, 2, 1. There. Okay, there's 1, 2, 2, 1. Thread one, thread two. Now thread one and thread two are asleep. Then thread two woke up. Well, thread two and thread one woke up at the same time, but thread two got scheduled ahead of thread one. Okay, so we've got 3 different orders there. Yeah, so we've seen 3 different orders of those threads running. 1, 2, 1, 2, 1, 2, 1, 2, 2, 1, 2, 1, 221, and probably will never see. You could get 2112 or several. You can't get 221. That's not going to happen because when thread 1 and thread 2 they start up, they both sleep for a second. So you're never going to see thread 1 finish before thread 2 starts. That's just never going to happen. So there's not an infinite. There's only a few possible scheduling orders. Okay, probably will not see 2112. I bet we won't ever see. If you probably have to run this a gazillion times to see 2112 because that would just be kind of quirky. But we did get at least several different orders. Okay, so they're really running independently of each other. They're really threads now. Okay, now this was using the implements runnable strategy of Java. Okay, now let's look at the other strategy. The other strategy here's the extends thread, but this is running it as a function. So there's the function wrapped in a thread class, not okay. And then here's how you make it into a thread. Okay. Okay. So okay. So there's the two parallel versions. Okay. Exact same thing going on down here. Exact same thing going on out here. This one creates two thread objects and just calls the functions. See, now again, creating a thread object is not creating a thread. So many people goof this up in Java. They think thread objects are threads. Unfortunately, that's not true. You need a thread object to create a thread, but a thread object is not a thread. It's a potential thread, but it's not a thread. So there's creating two thread objects, and then they're just running the function in them. Okay, here I have to go. Here's creating the two thread objects. Okay. So here it creates the two thread objects. This also creates the two thread objects. Okay. So create the two thread objects. Okay. Oh, I did. Notice that I have thread 1, thread 2 here, and here I have. Though I don't have thread 1, thread 2 here. Remember what I'm doing here is thread 1 extends thread. So thread 1 is a thread. So I can call this variable either a thread 1 variable or a thread variable. Over here, I happen to call it a thread 1 variable because T1, thread 1 is a thread, but it is a thread 1. Okay. So I think I could make them the same. Yeah. So I probably should have done that. See, it's a thread 1 object, but a thread 1 is a thread. So I could call the variable a thread variable. And that's actually the better way to do it. I should have had this as a thread variable. And over here, okay, so I have two thread variables. One thread variable points to a thread 1 object. The other thread variable points to a thread 2 object because each thread 1 and thread 2 are extensions of thread. Okay. Then over here, I ran the function inside the object. Here, I'm going to start the thread on the object. Okay. So instead of, in a way, this is the one that looks the most like the pthread version in a way. Okay. You create a thread object and then start the thread in the thread object. It's I'm sorry. Yeah, I'm sorry. You create the thread object, then start the thread in the object. Okay. Creating the thread object is not creating a thread. Creating a thread object is just, from Java's point of view, creating a thing called the thread object. The thread is not, threads are operating system things. Objects are Java language things. This creates an object in the heap. This creates a thread in the operating system. Very subtle distinctions. The thread in the operating system is this thread control block that represents an independent thread of control at thread of execution in our program. So the Java doesn't do that. The operating system does that. So this is Java's way of representing the thread from its point of view, but you still have to tell the operating system, make a thread out of this thing. That's done by the start function. Okay, then you can join them, wait for them. Okay, now if we compare this one with the one we just did a minute ago and here, okay, here's the one that implemented Runnable. Okay, and here's the one that extends thread. Okay, over here to create a thread, it's a little, it's more rigmarole this way. You create the objects that hold the function. You create the threads that hold the object that hold the function, and you start the thread. Okay, start the thread from the objects that hold references to the objects that hold the function. This looks more indirect, but this is actually the way most people do it. This is the more common way to do things in Java. This seems like it would be the easier way to do things, and it is easier, but it's less versatile. This creates the thread objects, which hold the runnable function, and then you start the threads in those objects. Okay, this looks like it'd be easier, and it looks a little bit closer to the pthread version, but in the long run, this is actually not the way most people do it. A lot of textbooks do it this way to begin with, but then they switch to this other way pretty quickly. This is the more general way. A class that implements Runnable, you wrap that in a thread object. Notice that these are thread objects. See over here, I have my own thread classes that extend thread. So this is a thread reference to a thread 1 object. This is a thread reference to a thread 2 object. These are thread references to thread objects. Okay, not subclasses of thread, actual thread objects. It can get confusing as heck. You know, like I say, that's why I thought the pthread version was a little bit better to start with. First of all, whenever somebody gives you more than one way to do something, you already are starting off at a disadvantage. You know, whenever a language says, here's more than one way to do something, it's almost always going to end up being confusing. Like, okay, when should I use this one way? When should I use this other way? Which is the right way? Yeah, and in the case of threads, I'm not really sure why Java gave us 2 ways of doing it. It leads to confusion because, like I said, some books just do this way, some books do just this way. It almost seems like you're reading about 2 different languages. Usually, if a book starts off this way, at some point they'll show the other way, or same. If a book starts off this way, they'll show the other way eventually. Some books show both ways, just like this. If you look at that good reference on the internet, this book here, he shows both ways. Okay, see, here's the way using the interface Runnable. Okay, then so he starts with the way that's the more general of the 2, which is the way that I say this is the way most people really do things. Okay, so you have this implements Runnable, then you create a thread object around it, and then you start it. Okay, so he puts it as a 5-step process. Okay, so here's his little, there's the steps we did in that code. And then then he also points out that you can do it the other way. In a couple pages, he gets to the other way. I'm trying to remember where that is now. Here's the other way. Then here he mentions the other way. And then he does an example using the other way. Okay. No, I'm sorry. No, that's not the other way yet. The other way is, oh, actually, no, maybe he did. I thought he did both ways. Maybe he doesn't. He's not doing the subclass. I thought he did both ways. No, he's doing the interface first. He's doing the interface first, then creating a thread out of the interface. I thought he did both strategies. Let me see if it's a little bit farther in it. No, actually, I'm sorry. He does it only one way. he seems to be doing all his examples create the longer way, which in the long run is more or less the way more people do it. You know, the one that requires more steps. See, he's doing it, implements Runnable. Yeah. So I'm sorry. So he does it just one way. Okay. Then if you look at another book, another book might only do it one way also, but the other way. Okay. So probably he does the other way somewhere in this chapter. I'm sure he's going to introduce both ways. Maybe it isn't until maybe he mentions it at the end of the chapter, because I'm sure it's in here somewhere. Okay. Okay. But that's one of the things that makes this stuff confusing from the point of view of Java, because there's two fundamental ways to create threads, and different people can point. Oh, let's look at this book here. Let's curious which strategy did he pick? I don't remember. He does it by extending thread. See, he does it the other way. Okay. So if you start, so he presents it the way of extending thread, not implementing Runnable. Okay. We'll see if he does both ways. Yeah, and then he switches to the other way. So he shows both ways, but he shows the shortcut way. He shows the shorter way first, then the longer way second. So he shows both of the ways. Okay. Okay. So it's a little bit tricky. Okay. Okay. Now, let's see. Now, what do we do next in the P threads? In the P thread versions, we started off with thread versus functions, calling them as functions. That was version 1. We did a couple, and then this was calling them as threads. Okay. Then version 3, this was the version that created a thread in one function and called the other one as a function. So now there's two threads. There's still the main, these two are running. This is kind of an interesting trick. These two are still running in parallel, because what we do is we create a new thread in this guy, and then let the main thread run through this guy. But then the main thread is running through this simultaneously while the new thread is running through this. So these two are still running in parallel. The other ones did 3 threads. See, the other ones did the main thread, which then created the other 2 threads and then went to sleep. And then there was one thread running this and one thread running this. Well, we don't really need 3 threads to do 2 things. So we already have the main thread. So why not have the main thread do one of these 2 things while a new thread does the other one? So in this case, the new thread ran this function and the main thread ran this function, but they ran in parallel. Okay, so if you run this, the 2 threads, these 2 run in parallel because they're running in independent threads. So we can do the same thing in a Java version. Okay, so here's oh, I thought I did that. No, maybe. Oh, that one isn't in the Java. There isn't a number 3 here. Okay. Notice that there's a whole bunch of different variations on the number 2. Okay, so let's look. Okay, so instead of doing the number 3, I'll add that later because it is actually kind of a neat way to do it. It's interesting to see how to do that in Java too, how to do it where you run one as a function and you run one as a thread. But let's just go through these and see. Notice that there's so many different versions. This is running 2 threads. Okay, so okay, version 1 is the one that used the example of implements Runnable, and version 2 is the one that extends thread. Okay, now let's see what version 3 is. Okay. Oh, this one starts showing you alternative ways to write the Java code. Okay, now this can get to be this. Now we're getting into pure Java object-oriented programming. Let's look at the simple example. I have a class that implements Runnable, and it's got a method in it. And I do that for one of the threads, and I do that for the other thread. Okay. Then I'm going to create I'm going to create objects out of those classes, and then create thread objects that hold a reference to these runnable objects. Okay. These classes can be moved inside of the main method. Okay. Right now, they're separate classes. If I go back over here, let me clean up a little bit. Let me delete all the class files, so you can kind of see what happens when we compile this. So I'm going to delete all the class files. Okay. Now compile this program here. Now, when I compile this program, there's this function, this class, that's one class. There's this class, there's this class. So that means I got three classes that need to be compiled. Okay. So if I compile this, okay, there's the three classes. Okay. The function one class, the function two class, and now these are private classes. They can only be used by that class there. These are actually private to that class. Normally you would take these and put them in their own file and make them public classes. Okay. But what's interesting is I can actually take these classes and move them inside main. So instead of having really three classes, I have only one class. These are called nested classes or inner classes. Okay. So that's what this one does. Okay. The syntax gets really, if you've never seen the syntax, it gets really strange. Okay. Remember, what I did over here was I defined a class, I instantiated an object, then I actually, no, I'm sorry, I want this version. I define a class that implements Runnable, I instantiate an object of that class, then I use that object to instantiate a thread object. So the thread object has a reference to the Runnable object, and the Runnable object is defined here. Here's the analogous code written in a really weird way. Here's the thread class being instantiated holding a anonymous runnable object. Okay. Over here, the runnable object was called function one, and it's written as a separate class. Here, I have what's called an anonymous inner class. It's got a very odd syntax. I say new runnable. See, new instantiates a constructor. So this should be a constructor. But I'm using the name of an interface, and I'm putting a pair of parentheses after it. What that does is it tells Java this is going to be what's called an anonymous class. So I say new run. Now, runnable is an interface. You cannot instantiate runnable objects. I have to create a class out of runnable, and I can instantiate that object, that class. But I can create an anonymous class that implements runnable using this special syntax. Okay. Then this guy here is exactly this guy here. Okay. There's the run method. Okay. See, that run method and that one, they're exactly the same. Okay. They're exactly the same run method. Okay. This one's just indented a little bit more. They're the exact same run method, but this run method is sitting inside of a class that implements the runnable interface. This run method is also sitting inside of a class, but the class is anonymous. It doesn't have a name. Okay. Okay. And then what that does is that builds the thread object around that anonymous object that is the runnable object. Then we start the two threads. Okay. Now, over here, we said there's three classes. There's this class, and this class. Okay, and we saw them over here. Function one, function two, and thread. Okay, now let me delete those. Now I'm going to compile this one. This one also has three classes. There's this class. There's the unnamed anonymous class that implements Runnable there. And there's another unnamed anonymous class implements Runnable there. Let's compile this and see what we get. Okay. There is that guy. These two guys are the anonymous classes. They're called thread versus function 2 version 1 $1 and thread versus function 2 versus version 3 $2. The $1 actually represents that class there. And the $2 represents, that's the second anonymous class. It represents this thing here. So I've still got, so you can see, I still have 3 classes. Okay, just like before, just like this one had 3 classes, but they were well spelled out. There was that class, and that class. You can see the 3 classes. This case, I'm using, now this syntax is really popular out there in the real world of Java programming. In fact, almost nobody writes this kind of stuff anymore. You notice this file is 60 lines long. This file is only 50 lines long. It's a lot shorter because I don't have to have all this extra code here for declaring this class and declaring this class. I can kind of fold those into this anonymous syntax. And as we go along, we'll see that there are other advantages to this anonymous inner class syntax. So what I'm doing is it's an anonymous inner class. Okay. So there's the new operator. So I'm instantiating something. Well, there's another new but here I'm instantiating a thread object. So I'm instantiating a thread object. The thread is written by the Java people. So I don't see thread compiled over here because thread's part of the Java library. But this is defining an anonymous class. It's defining, it's replacing that line of code there. Okay, well, actually, it's replacing this line of code here. It's instantiating an anonymous class. So the class name is $1. And this guy is actually becoming $2. Okay, so it's defining these classes, but in a much more compact way. But then what's inside the class is exactly the same thing. See, what's inside the class is exactly that. See that closing brace there? See here, there's this run method. There's the closing brace of the run method. Over here, here's the run method. There's the closing brace of the run method. The next closing brace came from the class. The closed parentheses came from the constructor call. The semicolon came from the end of the new. No, I'm sorry. This closing brace is the closing brace of run. The next closing brace is the closing brace of this constructor for the definition of the runnable. The parentheses close the constructor to the thread. And the semicolon ends this declaration of T1. Notice I get weird code. If I indent this like here, you get code where you get, it doesn't look like Java anymore. Semicolon, brace, brace, parentheses, brace, semicolon. You know, you start getting kind of quirky Java. And if you go look at other people's code, nobody knows how to indent these things. There's a lot of argument about how to indent these weird things where you're instantiating anonymous inner classes. I'm indenting it one way. Okay, there's a constructor call here. There's a constructor call here. There's a function declaration here. So I've got a constructor call, a constructor call, a function declaration, and different people take different points of view about how this should be properly formatted. And there's no real agreement on how to make this stuff readable. It can get to be very hard to you can write some pretty complicated nested anonymous inner classes. And then when you get to the end of it all, people just tend to pile up a bunch of braces and parentheses and semicolons. You can end up with 7 or 8, even 9 or 10. You got a string here of brace, brace, parentheses, parentheses, semicolon, brace, brace, semicolon, parentheses, semicolon. depending on how complicated this nesting is here, you can get some pretty weird terminating things here. Should it line up with this? Should it line up with this? Should it line up with this? And actually, people disagree about that stuff. What should this thing line up with? Should it line up there, there, or there? And you think that's a trivial matter, but people do debate these things because when it starts getting complicated, anything that helps you read it is helpful. And some people have different preferences of how this should be formatted. Okay, so all I've done from here to here is change something about the syntax of the language. Instead of using an explicitly named class that's private to this file, I'm using an anonymous class that's private to this file. Okay, so I've switched from a private class to an anonymous inner class. We'll see as we go along that there's some real neat advantages to this anonymous inner class. There's real subtle trade-offs about when this is a better way to code, when this is a better coding style, and when this is a better coding style. Okay, there are times when an explicit class name is better than an anonymous inner class. And there's times when an anonymous inner class is better than the explicitly named class. Okay, there's no hard and fast rules about which is the right way to do things. Now, when I talk about how this can be confusing to learn, I've seen textbooks that just jump in and do it this way from the start. Instead of like doing it this way, or the way, see, if you look at this, go back to this book here. He started off by using explicit. Yeah, he's explicitly writing the class the runnable. So he's not using this inner class syntax yet. Okay, but some books will just jump right in to the inner class syntax, which can be really hard to read. I think he also switches to the inner class syntax at some point. See if I can find any. I'm looking to see if I can find an example. See, he's still using explicit. He's explicitly using the runnable implements interface. He's not using the inner class notation yet. See, he's still using the explicit. Okay, he's not using the interface yet. I think at some point he does. Maybe not. Maybe he doesn't switch. Maybe maybe he's consistent and only does things one way in this whole chapter. I thought he switched. We're only halfway through the chapter. But that's one of the things that makes this stuff hard. If you go read somebody else's definition of threads in Java, first of all, they could be using the implements runnable strategy, or they could be using the extends threads strategy. They could be using the explicit class strategy, or they could be using the nested class strategy. So there's a whole bunch of ways they could explain this. And it almost feels like you're reading different languages when you jump from one to another. And one of the things I want you to start realizing is you have to start looking for what strategy are they using from the point of view of just style. Are they choosing the implements runnable style or the extends thread style? Are they using explicit class style or are they using anonymous class style? Okay, implements runnable, extends thread, explicit class names, in anonymous classes, in anonymous classes. That gives you a lot of choices. You can come up with a whole lot of programming strategies out of all those choices. Okay. It all boils down to something pretty straightforward, something real close to what we did in C. Basically, you need that function, and that's where the thread starts. You need that function that the thread can run in. And in Java, that function's always called run. But that run function can be sitting inside of something that extends the That run function can be sitting inside something that implements runnable. That run function can be sitting inside something that extends thread. That run function can be sitting here in an anonymous class. Okay. Now, here's another example. Here it uses the thread version with an anonymous class. Okay. So now I'm switching to the extends thread version with an anonymous class. Okay. So essentially we got four. See, that's why this one's numbered 4. We've got 4 strategies. Implements runnable, explicit class, implements runnable with a nested class, extends thread with an explicit class, and extends thread with an anonymous class. Most of this is just stylistic, but the styles, like I said, they almost look like different languages. Now you can start seeing why I wanted to start with P threads. There's only one way to do this in P threads. You know, the P thread strategy, there's only one strategy. You know, you define a function with that declaration, and you create a thread in that function. There's really no other choice. The function can have any name you want, but it's got to have that declaration. And you have to create the function. You have to create the thread using pthread create. Okay. Simplicity has its advantages and simplicity has its disadvantages. For initially starting out, this simplicity makes things a lot easier. But the pthread library is a low-level library. It doesn't have a lot of features. It's nice for getting started with, but if you need to write really elaborate parallel code, pthreads doesn't have it's not the tools for that. It's the tools for writing really low-level stuff, but it's simple. Java has got tools for writing much more sophisticated stuff, but they kind of probably over-engineered it a bit. Yeah. So and you can't just say I'm only going to do it one way, because you can say I'm only going to do it one way, but then somebody else is going to throw code at you that's written one of these other 4 ways, and you don't always have a choice of what code people throw at you. You know, if you're working for a company, if you're reading somebody's textbook, if you're reading somebody's papers, if you're working with somebody else, you don't control them. So now a company might have a style that says we're only going to use one of these styles, but you still have to work with library code. Even if a company writes their code only using one style, as soon as you use library code, that library code can be written in one of the other styles. You've got to be aware of all 4 of these styles in Java. Okay, so there's fundamentally 2 ideas: implements runnable or extends thread, and then there's explicit classes and anonymous classes. Okay, that's more. There's actually more variation than that too. These are called anonymous inner classes. There's also something called nested classes, and I don't know if I did the examples with nested classes. So you can use anonymous inner classes, or you can use nested classes, or you could use these explicit classes. Okay, these are explicit classes. Then there's explicit classes, nested classes, anonymous inner classes. Okay, so there's more than 4 styles. Okay, all right. So now we've gone through. Okay, so this at the beginning we had just two ways of describing the thread function, but not creating threads. So using implements runnable or using thread class, but neither of these actually created threads. Now we're going to go to creating threads. You can create the threads by implementing runnable, or you can create the threads by extending the thread class. Then you can do an anonymous inner runnable, or you can do an anonymous inner thread. Okay, so there's at least four ways of building the thread. Now the next example, if we went over here, we're going to skip. Notice we're going to skip this version 3, and we're going to go to the ones with arguments. Okay, here I numbered them 4. I should have numbered that 4. I can go back and clean this up a little bit. I should do the versions called 3 in Java, because I think those would be nice to see. So the versions that are called 3 here, I should have done them in Java. And now the ones we're going to switch to should have been thread versus function 4, starting here. This should have been a 4 because we're going to start with the arguments. How do you pass information into the thread function? Okay, so over here, okay, we want to start looking at how do you get information into the thread function? We know how to create the threads now, but the threads are not, we're not passing the thread any information. So the thread's going to always do the exact same thing every time. If we don't give the thread any input, the thread can't really, change its behavior. Okay. In the case of P threads, we use this pointer to void. That was the trick to get things in. Now, you would think that the Java people would use an object reference, that they would define a function that took an object reference, because object references are the equivalent of pointers to void. But the Java people actually were a little bit smarter than that. That wouldn't have been a great strategy. They picked a different strategy. They did not mimic this. Okay. This is one of the reasons why they have these run functions wrapped in an object. Here's my run. Now I'm switching to the strategy of an explicit class just to make things a little bit easier. So I'm going to notice that there's going to be a whole bunch of versions here because there's going to be extends runnable or implements runnable or extends thread, and there's anonymous versions. So there's going to be a bunch of different ways of doing this, but this is the simplest way here. Since this is a class, I can give this class fields. And since these fields are in the scope of the run method, they are its input. Okay. So when I instantiate this object, I can, and I didn't give it a constructor. So here, after I instantiate the object, I just poke numbers into the object. Okay. Now I could have given this guy a fancy constructor and then initialize these fields with a constructor, but I wanted to keep the lines of code as small as possible. It's really half a dozen of one or 6 of the other. I could either define a constructor down here, then use it up here, or in this case, there's no constructor, and then you poke numbers into those public fields. Okay, but that is the input to the thread. That's actually, I think, real clever. Use the object-oriented ability of the language. So instead of having, see, in C, there's no objects. So in C, there's nothing that this function can be wrapped inside of. Okay, so this function just sits there. So its function needs parameters. Okay, but in Java, the function must sit inside of an object. You cannot have functions in Java sitting by themselves. So the function must sit inside of an object. Well, as long as it's sitting inside of an object, let the object have parameter fields. Let the object have fields, so the function doesn't need parameters.
So what you're talking about is basically just a command pattern.
I don't think so. I'm not sure. The design pattern, the design pattern, the one called command pattern.
Yeah.
I don't know if this. I don't really pay much attention to design patterns. I don't really think that they're the greatest idea in the world. So I can't remember what is. Let's see. I don't know if this is command pattern or not. I don't remember. Like the patterns I know better are visitor and a couple others. Why do you think it's the command pattern?
Because you're encapsulating the function inside an object, and you can have properties in there, and that way you can execute it for later.
Okay. Well, yeah. An object used to encapsulate all the information needed to perform an action or trigger an event at a later time. Okay, yeah, that would be a good description. Yeah, the thread holds all the data that's going to need for when it starts up. Yeah, I didn't know that. So yeah, that would be the command pattern. Yeah, that sentence there describes it perfectly. An object that encapsulates all the information needed to perform an action at a later time. That's exactly what the thread's going to do. See, we instantiate the object here, and then later on, we start a thread in it. When we start the thread in it, the thread will use that information when the thread starts. Okay, good. So that would be an example of the command pattern. Okay. All right. So now it's kind of clever. Yeah, instead of, they could have given this function a parameter. And if they had, it would have pretty much had to have been a pointer to object. Because if it was a pointer to a string, it wouldn't be very useful. If it was an int, it wouldn't be very useful. Just like over here, to make that parameter useful, it needs to be able to point at just about anything. So in C, pointer to void, you can point at anything. Here, it would have been object, but then somebody must have been real clever and said, or, we don't need that parameter. Just go ahead and put the information in this object. Now, same thing for the return value. If this guy wants to have an output value, you can just use one of these fields as the output too. When the thread terminates, you can examine this object to see what values it left in these variables. So those variables act as both input and output. And that's another thing that makes this really clever. Those fields can be used for both input and output. So you could use them only for input, you could use them only for output, or you could use them for both. You could have some fields that are used for input to the object, and then you could have some other fields that are read at when the object is done as output fields. And in the world of Java, they do all of that. Okay, so you can use these fields either for input and output, or some fields for input, some fields for output. But the idea is that you don't need to return anything from this function, and you don't need to give any parameters to this function. That's the job of the fields of the class. Okay. Now here, I'm only using these fields as input. Oh, actually, no, I'm using it as input and output. Okay, so I'm putting input values in, and then see, I'm printing out the x at the end. So I'm using x and y as input, and I'm using x as the output. Okay, yeah, create an output value in x. Okay, so I'm using x as an in-out parameter and y as just an input parameter. Okay, and what each thread does is it just adds the two numbers together. It's going to take these two numbers and add them together and put the result in the x variable. I could add a z variable to be the result. So I could have had x and y as the input and z be the output, but I had x serve as the output. Okay, so if you compile this and run it, now they ran at the same time, so they also printed out this little messages. So they both all printed out the hello from blah 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 like before, but then they did this calculation using these numbers. So you get this jumbled up. If you run it several times, you'll get jumbled up outputs, but they'll always give you the same answers. Okay. Now here I'm using the implements runnable strategy. Okay. Then same idea with extends thread. It's an object. See, this function sitting inside of an object. So let the object hold the data that would be the input and the output. Okay. So I'm still encapsulating the run function inside of an object, so that object can also hold information that's the input and the output. Again, this one implemented runnable, this one extends thread. It's two different styles, but the key idea is that I can put the state information in there. Okay. And let's look at one more example. This one's going to use an anonymous inner class, but it's same idea. There's the there's the fields inside of the class. There's the fields inside of the class. It's just anonymous now, but the fields are there. So the class pretty much has the same syntax as any other class. This anonymous class, the syntax for it, this part of the syntax is exactly the same. From the opening brace to the closing brace, the syntax is no different. From the opening brace to the closing brace, the syntax is the same. This syntax is very different. See, class function implements runnable. Here, it's used this very weird. This is the anonymous class notation. New, the name of the interface, a pair of parentheses to make it look like a constructor call, but it's not really a constructor call, because this is the name not of a constructor, it's the name of interface. So then this is defining an anonymous inner class. And then after that pair of parentheses, there's a brace, which is another thing that signals the fact that this is not a constructor call. It's, see, there's the empty parameters, then followed by a brace. that's a syntax you only use in a case of anonymous classes. Okay, so this part of the syntax is unique compared, it's completely different than that, but between the braces is the same syntax for a class. So what goes there is the same syntax as what goes from there to there. That's the class. Okay. So I can do this, I can pass parameters even to my, if I use this notation of an anonymous inner class that implements thread, I can still use I can still pass it parameters. Okay. All right. So we run out of time. Look at these examples and read the references. If you read the references, keep in mind that we've seen essentially 4 strategies, and kind of pay attention to which one they're using. Are they extending Runnable or implementing threads? Are they implementing Runnable or extending thread? Are they using explicit classes, or are they using anonymous inner classes? Yeah, they'll kind of, a more advanced book will jump around between those strategies all over the place. Advanced books tend to start with one of them and then maybe introduce other strategies as they go along. But you kind of have, you have to translate. If you're, you have to realize that not everyone's going to write their code exactly the same way, because there's so many different strategies. Okay, any questions? Okay, so next week we'll start talking about synchronization. I think we've done pretty much everything in these examples here. There's a few little details like orphan thread and some other things that we can look at, but which are analogous to the examples from over here. Orphan thread, many threads. Where's the many? Okay. So we can finish the analogies between these two, but we're going to start looking at the race conditions and synchronization in Java. So we'll follow these folder up with the folder on race conditions and synchronization. Okay. So remember, on Tuesday, I forgot to mention this at the beginning of class, we're going to meet in a classroom again. Okay. Remember, we go back to school on Tuesday. Okay. So we're going to be in CLO room 210. Okay. So on Tuesday, we'll meet in CLO room 210. Okay. So if you have any questions, send me email. Otherwise, have a nice weekend. Bye-bye.